Good afternoon, my dear student. So, I have already started the module of the electric welding. Okay, after completing the other important module of the electrical utilization. So, in this module, we are going to discuss about different methodologies of the electric welding. And that welding is normally based on that idea of the electric heating. Okay, so electric heating means is also electric welding is also associated with electric heating. Okay, so we are based on the different we are based on the different methods of electric welding, and we are implementing the electric welding in different field of applications. Okay, so one common field of application is that fabrications. Okay, so we are using different soldering. Okay, like in our PCB boards, that is very common, that is very common and important applications in electrical engineering background. Those who are working in electronics engineering based on their different circuits, filter designing. Okay, so printed circuit board designing. Okay, so different rated circuit designing. So that welding is the most important thing. Basically, by this method you are joint. Okay, you are making joint between your components, electrical component, different active and passive components, different active and passive electrical components with the circuit. Okay, in PCB, or you say like that in Vero board. Okay, so that different examples are there. Okay, so last class I discussed about what is the importance of the electrical welding, then why it is important and how it is important. Okay, then I discussed about the different welding processes. Okay, I think all of you have gone through any of the standard books. Okay, for preparing your fair copy of class notes. Okay, so I am also suggesting that okay, so I have already suggested that what you need to do to submit the fair copy of class book class notes in coming Thursday. Okay, Friday is your exam based on your up to illuminations. Okay, so side by side I think you are take preparations for it. Okay, so then I discussed about the what is the definition of the welding, what are the different processes of electrical welding. Okay, then I discussed about different methodology. So that methodology I started with resistance welding. So it's like that your resistance heating. Okay, so the heat will be developed by generating I square RT, then we are using that heat for the welding purpose. Then I discussed about different advantages and disadvantages of the electric heat, means different resistance welding methodology. Then today I am going to discuss about some important some important ideas. Okay, today now I am going to discussing about the some important ideas on the resistive welding processes. So what are the most important features for the resistance welding? So today I am only discussed about the important features of the resistance welding and one classifications about it. Okay, so what are the most important parts of the resistance welding? First one is your bar welding, second one is your flash welding, then spot welding, steam welding, seam welding, and projection welding. Okay, so what was butt welding? So we are the joint where, so all of you about know butt joint. Okay, means two metal or non-metal, whatever your box piece will be there. So you are supposed to use some filler material to join between two areas. Okay, then you may use electric, then may use resistive heating methodology for it. Then flash welding is there. So one by one I am coming for that one. Okay, then spot welding, then seam welding, finally projection welding. So these five are the most important thing. Okay, then we will discuss about arc welding. Okay, so I am trying to complete today up to arc welding and resistance welding. What are the most important features on it? Okay, I think I also discussed about the different advantages and disadvantages of the disadvantages of the resistance welding as well as advantages disadvantages of the resistance welding. Okay, so I am not going to repeat it again. So our main thrust and most important part is that what are the most important features, what are the most important working principle of the different type of resistance welding. Okay, first we are starting with that butt welding. So from this figure you can understand what is butt welding. Okay, so you know that two metal pieces are there. Okay, so here you can understand. So that it is called the fixed platen. Okay, another one is your foregoing movable platen. Okay, like your movable platen means this one. So one will be fixed, another one will be movable. Okay, so clamping pressure is required. Here you are giving the pressure on it, means to for holding the objects. Okay, so that movable pattern direction of the welding. So from where it will be moving, so fixed point will be same. Okay, it will be fixed out. So another point it may be moving. Okay, so then you are tightening the, you can tighten the clamp, means workpiece. Okay, that one workpiece is here. Okay, for your fixed pattern, another is movable pattern. So another workpiece is there. Okay, so now we are going to move towards the fixed pattern. We are going to move the movable pattern towards the fixed pattern. So what is written here? So in this method, in this welding method, so we are employed to join the bars. Okay, join the bars and plates together end to end. Okay, so bar and plates were joined to end. Okay, so that's why it is called the butt joint, means it's area base joining is there. Okay, you can think about, you can realize that one in the area base surface. Okay, so that area you are going to be add. Okay, you are going to be joined. Okay, one bar is held in the fixed clamp. Okay, so one fixed clamp is there that can holding one bar. One bar means it's your test bar, means it's your work piece. Okay, so it is your workspace. So fixed clamp will be there. So in the bar welding machines, and other bar is movable clamp. One is fixed clamp that can hold the fixed plate, or you say like that fixed workspace. Another one is movable clamp that will hold the movable plate or movable workspace. Okay, the clamp being electrically insulated. Okay, so definitely that electrically insulated, if it is not electrically insulated, so current will flow, so you are getting shocked. Okay, basically body should be insulated, otherwise what happens that if it is not insulated in bare, so definitely high chance to the faults as well as shocking problem. Okay, the one of the end, one from the other and being connected is surface current. Okay, connected to the source current. Okay, so current is flowing towards the fixed workspace and the movable workspace. Okay, when two ends are joined, are brought into the contact, the current is current is switched on, and the resistance at the joint cause the end to heat up to the welding temperature. Okay, current is then switched off, the movable clamp forced up, and so the weld is made. The voltage applied across the clamp is low 1 and from 2 to 6 volt when the current is usually alternating. So why that voltage is very less? Basically, if it is short circuited condition, so voltage will be tends to 0, nearer to the 0, but there will be huge current. So I think all of you are able to understand. So you are first touching with your fixed movable workspace to the fixed workspace, then you are turn on that switch. Okay, after turning on that switch, then current is flowing through your both of the workspace. Then what happens? Due to current flowing, there will be heat generation, I square RT. Then you are try to detach your movable platen from your fixed platen. Then what happens? After switching off that one, so it will be at the temperature. That plate will be melting. Okay, the face of the plate will be melting and it will be jointed. Okay, that's the way you say like that, it will bar welding. So there is a very less voltage. Basically, it is short path, short circuit path, so voltage level is very less, but current level is very high. Okay, so if the bars are being joined are different in cross section. Okay, then what happen if they are having different cross section? Then what happen? So the amounts they project from their clamps may have to be adjusted so as to modify the heat losses and ensure both bars being brought to the welding temperature simultaneously. So again, what happens that if both are in the, there are different possibilities. Okay, if they are not in the same, the space are not same, then what happen? The process will be same, that how much you are getting connecting, so that portion will be connected. Okay, basically you can stretch some of the portion, so it will be connected. That is number one. Number two point is that, so if it is reached the temperature and if after melting down, what you need to do, you have to switch off the connections. If you are able to switch off it, so definitely it will be joined. Okay, so it having different cross sectional areas. Okay, I think all of you are able to understand. This process is being used for the welding source. Such thing are the steel rails. What are the most important things? Steel rails whose cross section area are as much as 6.25 centimeter square. Okay, so steel rail means you can see that you are traveling in the train. Okay, sometimes you can see that if you minutely observe the track, okay, railway track, where you can see different welding. Okay, so both the track are welded. Okay, means not both the track. So one line you can see that lines are welded. Okay, that's a very good welding. Okay, so sometime that welding also done, you can see there is no gap. Okay, there is no gapping. Okay, that welding is very good and that there is no gapping in between two line that are welded. Okay, but sometimes you can see two tracks means sometimes you can see that tracks are also connected to a screw. Okay, screw it will be connected, but there is some space. Why that space is there? Basically train is moving just with the railway tracks. Okay, so there is a huge frictional force. Due to the frictional force, huge means heat energy may be developed. Due to the heat energy, the temperature may change. Okay, that temperature may change means there is a expansions of the railway track. So that's why when you are preparing the joint on the railway track by the screw, when you are doing the joint from the screw, so there is a, you can see that 1 inch gaps are there. Okay, more or less 1 to 1.5 inch. Okay, not more than that. Otherwise, if you make the more gaps means there is a contact, there is a problem for the contact losing of your railway track and the rail wheel. Okay, so where that welding also doing, that kinds of welding is called bar welding. Okay, when you are traveling next time, you please see minutely. Okay, so chain is a very good applications of electrical energy. Okay, so electrical engineering science, it's a very good application. So if you see minutely the electric chains or locomotives, you can understand lot of things. How the can you imagine, so in the power system, how the ground, we are using the earth as a ground. Okay, imagine that kinds of thing. In electrical engineering, you have to realize the problem. Okay, so first realize how it will be working, then what is the tentative circuit. So all the system having some circuits. Okay, so electric current flowing path. Okay, so you have to realize the circuit. Okay, so after that we can discuss about the flash welding. So from the definition you can understand. So one flash will be flash or arc. Okay, when the flash or arc will be developed. Okay, so due to that arc, so you can see that two of the contacts. Okay, so that arcing arcs are there. So two contact, again that movable one is fixed one, another one is movable platen. Okay, both are there. That is called fixed one. Okay, so clamping is there. Okay, that is a workpiece that I am telling you, that workpiece, movable workpiece. So it is movable towards your fixed workspace. Okay, so it is your fixed workspace. So two electrodes are there. Okay, one is cathode, one is anode. So you say like that. Exactly, it's not cathode anode type. Okay, so transformer plus minus terminals are given. Okay, so connected to the high voltage transformer. So transformer having very high voltage. Okay, so very high voltage means in this plane. Okay, so in this space. Okay, so arcs line will be developed. Means air will be broken down. Okay, air will be broken down in between the fixed and then movable workspace. Okay, so air broken down means the flash. Okay, electric flash will be there. Okay, due to electric flash it will be due to electric flash what happened, it will be jointed. Okay, so here you see the diagram before welding how it will be look like. So it's your both of the workspace are there. Okay, one is one is a fixed work plane, fixed plane, clamping with that one, another one is your movable. Okay, so after the welding you can see it will be joint like. So how the heat will be produced due to the arcing effect. So arc will be there or the flashing will be there. So it will be developed. So it is called the flash welding. So simple thing you can understand from the diagram. Okay, what is written in this process? The part of the welding are clamped. Okay, so from where it will be clamped with the electrode. Okay, which having fixed fixers. Okay, bar welding, but the voltage is applied before the part are barred together. So huge voltage is applied. So what is the difference with that bar welding? So bar welding you are only applied 2 to 6 volts. No, it is written. Okay, so only 2 to 6 volt, very less voltage, but huge current. But here high voltage is applied. That's why you are implemented one transformer. Okay, as the part of the as the parts touch each other, an arc is established which continues as long as the parts advance at the correct speed. Okay, correct speed, and the arc burst away a portions of the material from each space. Okay, you can understand. When the welding temperature is reached, the speed of the travel is increased. Travel means that arc travel. Okay, so how fast it is traveling. The power switched off and the weld is upset. Okay, so power will be switched off and welding is upset. Okay, both the way it is work. Flash bar welding claims forward advantages over the upset method of the welding. Okay, so what are the advantages? The power consumed is less. Okay, the arc creates the more heat given with a given current. So heat means arc means it's a flowing of the current, breaking down of the air. So it's a flowing of the current. Okay, that is first one. Second point, what is the second point? The weld is made. The weld is made in clean virgin metals as the surface are burned. Okay, so that is your clean surface. There should not be any kinds of means rusting, any kinds of dusting, one means dust, any kind of dirt. Okay, so that should, why it is not required, basically if any kinds of dirt are there or dust are there, so that may damage, that may creates void. Okay, so when that rails are welded means, so there are infrared testing is there. Okay, so huge pressure testing is there. So if you visit any of the power plant, okay, so testing is another important issue in electrical engineering. What happened, where in measurement. Okay, so what happened, we are doing normally calibrations. Okay, then another important point is your testing. Okay, so what kinds of testing we are doing? So in case of machine, so you know that we are using the insulator, oil impregnated pressure insulator, oil impregnated paper insulator. Okay, so how would I testing that one? So we are doing the vacuum test. Okay, so there is a vacuum tank. We are providing that directly immerse all those insulator, all those machines. Okay, inside of the vacuum tank in any of the workshop. If you go different machine designing shop. Okay, so you can see how the winding, simplex winding, duplex winding. Okay, so different means as per your designing, that windings are there. Means stator winding, means LT winding, HT winding. They know only two terms, LT and HT. So what about their HT range? Okay, and what about their LT range? Everything is given as per their standard. They are mentioned. Okay, so HT winding, LT winding. So if you go to the RSP means machine shop, okay, or winding shop, you can see different parts. Okay, so different important features are there. Okay, so testing is important. So that's why I am telling about the railway track. So they are testing for the void test. Okay, if there is any void inside of the welding material, then what happen? Huge mass of train is moving just upper side of your tracks. Okay, so huge heat will be developed, that may cause for cracking of your material, means void will be also expanded. Void means there will be, it's not possible na, so vacuum is not practically possible, so somehow some of the air is there. Okay, so huge heat energy means expansion of the air material, so that may day by day what happen, that void may creates the cracking of your substance. So that's why it should be cleaned. Okay, when you are doing the welding, okay, well clean, and it should be the smooth surface. Okay, that's the reason. Then more quicker. Okay, so arc welding means it will be do the very fast one. Okay, so quickly it will be joined together. Okay, so application, it is widely used, okay, in automobile construction, on the body, axle, wheels, frames and other parts, okay, of the car. Automobile industry means car, you know that one. It is also employed in welding motor frames, transformers, tank, and the many types of the sheet steel containers, such as the barrel and the floats. So if you see different oil barrels, that welding you can also see. Am I audible?
Yes, sir.
Sorry for the interruption. Basically, the current was gone in our department. So my slide is visible from your side.
Yes, sir.
Okay. So I am discussing about the flash welding. Okay. So flash welding slide is visible from your side.
Yes, sir.
Yes, sir.
Okay, good. So that I discussed about it. So what are the applications of the different flash welding? So you know that I have already told you. So the constructions of the different bodies of the automobiles and different daily life application like barrel floaters. Okay, so different applications are there. Then we should discuss about the spot welding. It's another example of a resistive welding. So from the title you can understand what is spot welding. So spot welding means you know that you are specifically you can two workspace are there, so you can see that both of the workspace in placed just above one. Okay, so then clampings are there, then you are two, it's like that a water cooled electrodes. Okay, two electrodes are there. Okay, one electrode, another electrodes are there, both side the clamps are there, so for holding out that plate. So two plates are there, so you are making that welding. So two plates by the spot means you know that pin tip electrodes are there, so you just place two pin tip electrodes just face to face. Okay, and and the between of these two pin tipped electrodes, so some plates are there. Okay, so plate to be welded, that plates are there. Okay, so now what happened, your main supply is there. Okay, so main supply means transformer is there. Okay, so you are providing that very high voltage, and the choke coil is there for producing the high voltage. So what happened, that high voltage is appear across these two at certain temperature, sorry, at certain voltage. So it will be break down that medium, so plate will be breaking down and huge current will be flow inside of that plate, and current will flow from one electrode to another electrode. So you see that terminologies of the electrode is connected. So if the current is flowing in between two plates, so what happened, it will be joint, only that positions, that pinpoints positions is joint. Okay, so here you know that top view after joining. Okay, so plates are top viewed at there, the top view of the plates are there, they have joined together. Okay, it is a spot weld. Okay, so what is written here, so you know that one, the steel, okay, brass, copper examples, and light alloys. Okay, normally these are using for that, can be joined by this method. Okay, these are using where you are using the spot welding for jointing them. So what are the metals? Steel, brass, copper, and the light alloys. Okay, in this method, which forms a cheap and satisfactory substitute of riveting. Riveting means what? You are drilling two of the metal, and in between you are placing nut bolt. Okay. So what happened? You can sometimes there is a losing. If riveting, what happened? You are using riveting in the track, railway track. Then what happened? So there is a huge frictional force that may cause sometimes losing of the nut bolts. Okay, so there is a disadvantage of riveting. Riveting is a good options. Okay, bimetallic strips. That's the example of a riveting that also been used in the fluorescent lamp. Okay, so all of you please study that different structure of the lights. Okay, basically operation principle. Okay, so the riveting is normally done, okay, for connecting two of the material, okay, with you by using the nut bolt, screw and nut bolt. Okay, but here you are using what, you are using the spot welding. Two plates are there, now you are providing the high voltage, so they are melting, that point only melting and connected each other. Okay, the area of fusion, at each spot weld, in fact, is approximately equal to the cross sectional area of the rivet. Okay, area of the rivet which would be employed for the similar gauge of materials. Okay, I think all of you will understand simple thing. Then spot welding, as the name of implies, it carry out the overlapping. Okay, so carry out of the overlapping the edges. Okay, overlapping the edges of two sheets of metal and fusing them together between the copper electrode tip at suitable space intervals by means of the heavily electrical current. So electrodes are there, so you know that there is this interval, space interval between the copper weldings. Okay, so you are using copper materials. Okay, as a copper as a material of electrodes. Okay, so then you are connecting means that points are soldered. It is called soldering, means welded. Okay, the resistance offered, okay, the resistance offered to the current as it passes through the material rises the temperature of the material between electrodes to welding heat. Okay, so all of you can understand. So heat is the basic primary object, primary requirement, means prerequisite, and who are developed for that heat. So electricity is used for developing the heat. That's why it is called electric heating. Okay, the current is cut off and the and the mechanical pressure is then applied by the electrodes to forge the weld. Finally, electrodes open. So how much time it will be turned on, that is welded, so that amount of time it will be turned on, rest of the time it will be, it will not work. Okay, so I think all of you are able to understand. There is no doubt till now. So then finally that electrode will be open. Okay, so that's the basic operations of the spot welding. Okay, after the spot welding, what happened? Another two welding methods are there, that is seam welding and projection welding. Okay, then we have discussed about, okay, another some important points are there. So in spot welding, when the steels sheets of unequal thickness, spot welding, what happened? It is also applicable for unequal thickness joint. Okay, so it is also possible. So in previous case, if you go for unequal joint, so there is a problem. Okay, but spot welding normally happen. It is the surface to surface. Okay, surface to surface it is joint, but butt welding it is face to face joint. Okay, butt welding and arc welding, that flashing welding, you can see that is face to face joint. Okay, so butt welding is normally Am I audible?
Yes, sir.
Yes, sir.
Okay, I think my slide also visible from your side.
Yes, sir.
Okay. Okay, so I was spot welding. So another important points for the that I was discussed that in case of seat actually in spot welding that surfaces were going to be joint. Okay, the both the surface were just attached with that spot welding. That is not happened in case of butt welding or flash welding. Okay, the current and pressure setting is for the thinner sheet are used. Okay, so as it is not face to face communication welding, so sheet it depends upon the thickness of the sheet. So as per your rating of that welding machine, so you can change sizing of the sheet, means thickness of the sheet. Okay. So four thickness may be welded using same settings of the two thickness. Okay. The spot welding is used for galvanized tine and the lead coated sheet and the mild sheet. Okay, together technique is also applied for the non-ferrous materials such as brass, aluminium, nickel, and the bronze, etc. Okay, these all are the very basic features of the spot welding. Now, what is seam welding? Okay, so from the diagram you can see seam welding means it's look like a spot welding, but there was in case of tiny, you know that was that electrodes are tiny in nature. Okay, very small focused electrode, but here the electrode is not so tiny in nature. Okay, so seam welding, you can see that cross section area, so that dark portions, okay, that dark portion is welded with the workspace. So one is clamp. Okay, so one is fixed clamp. Okay, AC main supply is there. Okay, roller is there, one positive roller and negative roller. Between this roller that electrodes are there. You can see two of the electrode, that is a workspace. Okay, workspace is here. Okay, so clamping are there for finding out that rollers. Okay, plated to be welded. So supply leads are there, both the supply you are giving plus and minus. Okay, that's the figure of the seam welding. Okay, so now what are the features of the seam welding? Many important points. The seam welding, okay, is analogous to the spot welding. Okay, it's look like the similar the spot welding. Okay, with the difference in the electrodes are in the form of rollers. Okay, in case of spot welding, it was tiny in nature, means very focused tip. Now it is look like a roller. Okay, and the wax moves in the direction perpendicular to the roller axis. Okay, so it work should be the perpendicular to the roller axis, so it may be moves. Okay, the current is interrupted 300 to 1500 times in a minute to give the series overlapping spot weld. Okay, so multiple spot welding will be observed here. Okay, it's a roller, so not like only single area, I mean single spot of electrodes. It's a huge lot of single point, means it's a cross section area, so it will be moving over there. Okay, so that's why that overlapping of the spot weldings. Okay, the weldings is usually done under the water to keep the heating of the welding roller or and the work to a minimum, thus the give the lower roller maintenance less distortions of the work. Okay, so that's the basic features on it. So gradually you have to work on it. So cooling is important. As far as it will be cooled down, so welding will be happened. Okay, the seam welding is confirmed. Seam welding is confined to welding thin materials ranging the thickness up to 2 mm to 5 mm. Okay, so it is also restricted to the metals giving low hardenability rating and the hot roll grade of low alloy steels. Okay, so these all are having some restriction, you cannot use for that one. Okay, so those having low hardenability means it will be broken if you give the welding, so automatically it will be broken. So most of the cases metallic part you have to choose it. Okay, so elasticity, more elastic material should require. Okay, it is employed on many types of pressures. Okay, you can employ this lot of pressure on it. So light or leak proof, that's another pressure tank. Light types of pressure tanks for the oil switches, then transformers, okay, refrigerators, evaporators, and the condensers, the aircraft tank, paints, and the varnish containers. Okay, these all are the basic features and where we are going to be implemented that type of welding. Okay, so spot welding, sorry, it is your seam welding. Okay, so I think you are able to understand that what are the basic topologies of the welding, of the different resistive welding. So last one is pending, that is called the projection welding. Okay, so what happened in the projection welding? The same thing. Okay, so you are projecting. So here you can see two metal works are there. Okay, so one is insert and insert and the projector. Okay, so again the clamping is there, high voltage you have to apply it in the projection welding. Okay, so supply is there, then transformer having two coils. Okay, so then it is die blocks, so two blocks are required, one is movable platen, another one is fixed platen. Okay, so it is a projection welding. So here you know that one, that workpiece are there, one is fixed cross sectional area, another one is like a variable. Okay, the cross section area is changing. Okay, so here you are providing the pressure. Okay, welding pressure you are providing. So welding pressures are there. So here you can see that pressure. So only that tip. Okay, the projection top view. So both the top surface of the, okay, both the surface will be connected. So that's why it is called projection. So what is written? So it is effect, a form of multi-spot welding. Okay, so here you know that multi-spot, one spot here, another spot is here. So if you more up and downs are there, so more spotting will be there. Okay, in which a number of weld are made simultaneously. Okay, so number of weld is making simultaneously. The pieces to be welded are arranged between two flat electrodes. Okay, two flat electrodes are there. Okay, which exert the pressure as the current flows. Okay, electrodes are there means pressures as well as the current flow, both will be done. Okay, the projections and the projections and the areas with which they make contact. Okay, the projections means where it will be contact. Okay, are rise to welding heat and are joined by the pressure exerted by the electrodes. Okay, so pressure where it will be exerted, so on the electrodes. Okay, the projections are flattened. Okay, flattened during the welding. So here you know that multiple spot welding will be there. So one workspace is there, another, both of the workspace is there, one is fixed workspace, another is movable workspace. So that portion are bending and touching with the surface, that portion is only welded. So I think understand what is the projections welding. So today I have discussed up to the different ideas and different applications, different methodologies of the resistive welding. Okay, so here I am going to conclude today's lecture. Okay, so in the next class, in my next lecture, we will discuss about different other welding methods. Okay,